So let's talk about what periodic functions are. So in the last section, it was found that sine of 7 pi equaled sine of pi, which both were 0. So remember that when we had our circle, the sine of pi would put me right here at pi, which was 0, and 7 pi would be 1, 2, 3, 4, 5, 6, 7, so it puts us right in that same position. And in fact, this isn't the only angle that produces the sine of 0. There's a ton of others. So some of those other ones are going to be, like we could do, let's see. So we've got the sine of 7 pi equals 0, the sine of pi equals 0. What about the sine of 1, 2, 3 pi? That's going to land us in that same spot. The sine of 1, 2, 3, 4, 5 pi, that lands us in the same spot. So you can see there's going to be an infinite amount of values, of input values, that will give us an output of 0. So when a function repeats its values in regular intervals, it's known as being a periodic function. So for cosine and sine, how often do those outputs repeat themselves? So if you're looking at a unit circle, to go all the way around, is going to be 2 pi. So therefore, the period of the cosine and sine function is 2 pi, or if we're talking about things in terms of degrees, it'd be 360. So again, for sine and cosine, sine's going to be positive here, negative, negative. So we've got to make sure that we're including all of those values. When it comes to tangent, it's going to be a little bit different for where it's periodic. So let's continue on this. So what is the period of the tangent function and how often does it repeat itself? So here's a table of values that we have that will help us determine this. So you can see here's the values for x, here's the value for the tangent function. So we're good, no repeats here, no repeats here, no repeats, no repeats, but then it looks like right when we get to pi, we start repeating these output values. We've got 0 again, then we've got root 3 over 2, or 3 over 3, and then we've got 1, and then root 3, undefined. So it looks like here's another cycle. So you can see it's periodic, it starts repeating itself at pi units. So what we would say is that the period of the tangent function is pi. If we're talking about this in terms of degrees, that would be 180 degrees. Since the cotangent function comes from the tangent function, its period is the same. So for example, the sine of theta plus 2 pi k is the same thing as the sine of theta plus 360k degrees, which equals the sine of theta. So just to give you an idea of what this is a formula for you to know, but just where it comes from. If you think about it, so let's just say that theta is pi. So this is saying that the sine of pi is equal to the sine of pi plus, and k is an integer, so like if k was 1, it'd be 2 pi times 1, which is 2 pi. So that would give us, oops, this should be the sine. The sine of 3 pi, which we already said earlier, the sine of pi and the sine of 3 pi were both 0. Same thing, if I let k equal 2, then I'd have the sine of pi plus 2 pi times 2, because now that k value is 2. So that gives me sine of 5 pi, which of course is the same thing as the sine of pi. 5 pi is going to put us at 1, 2, 3, 4, 5. So right at that same spot, the sine of pi. So we can do the same thing similarly for cosine, and then for tangent, that period is pi. So that's where that part comes from. So let's look at an example. Use the fact that trigonometric functions are periodic to find the exact value of each expression. So what we could do is we could rewrite this as the sine of 60 degrees plus 360 degrees. And using that formula that we had before, we know on this last page where it was the sine of theta plus 360 degree k is the same thing as the sine of theta. So I can say this is the same thing as the sine of 60, and using our table that we learned in the last section, we know that the sine of 60 is root 3 over 2. Now, I think that's great. In my opinion though, I think what's easier to do for these guys is, instead of using this idea of periodic, is just to see where you're at in the unit circle and then use reference angles. So the way that I would do this problem, and again, you can choose whichever way is the most makes the most sense to you, is I would look at where's 420 degrees. So there's 360, and then I'm 60 degrees more than that to get to that 420. So my reference angle is 60 degrees, and I know that the sine of 60 degrees is √3/2. So looking at this in this quadrant, is sine positive or negative? Well, sine deals with the y values, which is positive there, so that means the sine of 420 degrees is √3/2. Okay, looking at tangent. So I could rewrite this one. I'm going to do it both ways. I'll do it with reference angles, and then I'll do it without reference angles. So if I take 21 pi over 4, I'm just going to kind of reduce this. So let's take 4 and see how many times it goes into 21. So it's going to go into 21 5 times, and we'll have 1 left over. So that means that I can rewrite the tangent of 21 pi over 4 as, as 5 pi plus my remainder 1, so 1 pi over 4. All right, so using the fact of periodic functions, you could go back and do that. Tangent of theta is equal to the tangent of theta plus pi k. So here you can see that that k value would be 5. So this is the same thing as the tangent of pi over 4. And again, looking at our chart that hopefully you have in front of you, that unit circle chart, as well as that little table, we know that the tangent of pi over 4 is 1. So that's using this formula. Using reference angles, it's just going through. All right, so again, 21 pi over 4 is equal to, so 21 pi over 4 is equal to 5 pi plus pi over 4. And again, this is going to be crucial to reminding you guys how to divide. Is we're going to take these and figure out what our whole number is, which is the 5, and then you tack on that pi, and then whatever your remainder is what you're going to write over that denominator. So for example, if you had, let's do 34 pi over 4, that would be taking 4, putting it into 34. So 4 goes into 34 8 times. So there would be 2 remainder, so 8 with remainder 2. So we would say that 34 pi over 4 is equal to 8 pi plus a remainder of 2, so 2 pi over 4, which reduces to 8 pi plus pi over 2. Okay, so for figuring out, so for graphing this one, 5 pi, so 1, 2, 3, 4, 5, and then we've got a pi over 4 that's left here. Oops. So pi over 4. So that means my reference angle is going to be pi over 4. The tangent of pi over 4 is 1. And then I just have to pay attention to if tangent is positive or negative in this quadrant. So tangent is sine over cosine. So in this third quadrant, sine, which is the y values, is negative. Cosine, which is the x values, is negative. And a negative divided by a negative is a positive.